All right, so in this video, we're going to factor by grouping. So this is going to help you with the last section on O3 Part 2. Okay, so the Solving Rational Equations worksheet. At the bottom, there's this section that says solve each by factoring, and in parentheses, factor by grouping. So to factor by grouping, we have to think about this. Well, notice first that there's 4 terms, okay? So anytime there's 4 terms and you're factoring, that probably means you're going to be factoring by grouping. So we're going to actually be grouping the first 2 terms together and grouping the last 2 terms together, and then we're going to be looking for common factors. So that's going to be our first step. So let's try that. All right, so we're going to go ahead and we're going to group the first 2 together just using parentheses, and we're going to group the last 2 terms using parentheses. We have to be careful here because there's a minus between here. And I don't want to put the parenthesis in front of the minus because that would say I'm going to multiply this part of the equation by this part. And that's not what we're doing here, right? This is subtracting, so there's nothing being multiplied. So I need to put my parenthesis here, but if I do that, that's going to change the problem as well because then now that the parentheses are there, that would mean I would need to distribute the negative to the 25 as well as the negative 25. And that would change this to a positive 25, and in this equation, that's not a positive 25, it's a negative 25, and we need it to stay that way. So if you see a minus in the middle and you're grouping those last 2 terms together, go ahead and take that negative and pull it in front, so it's only in front of 25, and then change that one to a plus, okay? So this stuff here is still added together. There's no multiplication. So this is still exactly the same equation. We've just grouped the first 2 and last 2 terms together. So now what we want to do is we want to look at the first 2 terms and find their greatest common factor. So the greatest common factor between x to the 4th and x to the 6th is x to the 4th. So I'm going to pull an x to the 4th out in front of the parentheses. And again, I'm just looking at these 2 terms. So if I pull x to the 4th away from x to the 6th, that's going to leave x squared. And then x to the 4th, I pulled the whole thing, which means there's going to be a 1 here. Right? I can't just take it and leave it. It's not going to become a 0 because when I multiply this back into the parentheses, I need to get the same thing back. I would need to get x to the 6th plus x to the 4th. So make sure you put that 1 there when you're taking the whole thing as a placeholder. Okay. Next, we're going to look at the second parentheses, and because our first term is negative, I'm going to pull out a negative. It looks like the common factor here is 25, so I'm going to pull out negative 25, which will leave x squared plus 1. Okay, it would change it to positive here because I pulled a negative 25 out front. Now notice that I have x squared plus 1 in parentheses here. Also, I have x squared plus 1 in parentheses here. Now just like above here when I pulled out 25 or negative 25 because that was the common factor between these 2 terms, I'm going to pull out the common factor in the entire expression now, right? And because x to the 4th is times by x squared plus 1, and 25 is times by x squared plus 1, that means that my common factor is x squared plus 1, and I can pull out x squared plus 1 in front of the parentheses, and what would be left is just x to the 4th minus 25, and then everything equals 0, okay? So now x to the 4th minus 25, I can continue factoring that. I can think of this x to the 4th as x squared, and I can x factor it. So a would be 1, and c would be negative 25. And b is not there, so it would be a 0. So I'm looking for 2 numbers that multiply to negative 25 and add to 0. That would be 5 and negative 5, right? But again, this was x to the 4th, not x squared, so I need to write x squared here and here. So that would be x squared plus 5 and x squared minus 5. Alternatively, I could have noticed that x to the 4th is a perfect square. It's x squared squared. And I could have noticed that 25 is 5 squared, and then I could just write it down x squared plus 5, x squared minus 5, because it's a difference of squares. X squared plus 1 is still here multiplied in front. And now I can solve each of these by setting them equal to 0 and solve for x, right? So x squared plus 5 equals 0 and x squared minus 5 equals 0. So on the first one, I would subtract 1 from both sides. I'm going to move up here. That would give me x squared equals -1. So when I take the square root of that, I'm taking the square root of a negative, which means this is going to be an imaginary solution. The square root of 1 is just 1, right? So the square root is going to go away, and it's just going to be plus or minus I. So that's 2 of the solutions, positive I and negative I. This should have 6, right? So from our next one over here, x squared plus 5, I'm going to subtract 5 from both sides, and that's going to give me x squared equals -5. Again, if I take the square root of a negative, that is imaginary, so plus or minus I and times the square root of 5 are my other 2 solutions. And then lastly, from x squared minus 5, I would add 5 to both sides, which gives me x squared equals 5. Take the square root of both sides, and x equals plus or minus square root 5. So those are our 6 solutions, okay? So let's try another one. So on this one, I'm going to group the first 2 terms. I'm going to group the last 2 terms. Again, there's a negative there instead of a positive, so I need to pull the negative in and turn it into a positive. Now I'm looking for common factors on the first 2 terms, which again would be x to the 4th, which would leave x squared minus 3. And here, if I pull out a -1, since my leading coefficient is negative, that will leave me with x squared minus 3. Right? -1 times x squared is negative x squared. -1 times -3 is positive 3. Now notice that x squared minus 3 matches here and here, so I'm going to pull that out front. And what would be left was x to the 4th minus 1 equals 0. Again, I've got an x to the 4th, but this is a difference of perfect squares, so I know this is going to be x squared plus 1 times x squared minus 1. If you wanted to use x factoring to convince yourself of that, you could do that. And now we take each of these factors and set them equal to 0. So on this one, x squared minus 3 equals 0. I would have to add 3 to both sides. So x squared equals 3. Take the square root. X equals plus or minus the square root of 3. There's 2 of our 6 solutions. X squared plus 1 equals 0. I would subtract 1 from both sides. So x squared equals -1. When I take the square root of that, I'm getting the square root of the square root of a negative, which means it's imaginary, and the square root of 1 is 1, so it would just be plus or minus 1i, or I. And for the third one, x squared minus 1 equals 0, I would add 1 to both sides. So x squared equals 1, which means x equals plus or minus 1, because the square root of 1 is 1. Okay? So I'm going to pull up one more example. I would think it would be a good idea here for you to pause the video and try the example. So you're going to try number 17 on your own first, and then come back and watch and see if you got it right or to catch your mistakes, okay? So I'm going to group the first 2. I'm going to group the last 2. Since it's negative between, I'm going to pull that negative in. If it were positive between, I wouldn't have to worry. I could just put the parentheses there and leave the positive in the middle. On these first 2 terms, again, I've got x to the 4th that I'm pulling, which would leave x squared plus 4. Here I'm going to pull out -9. And that's going to leave me with x squared plus 4 equals 0. Okay. So now I see that my common factor is now x squared plus 4. So I'm going to pull x squared plus 4 out front. And what would be left is x to the 4th minus 9. Again, a difference of perfect squares. So that's going to be x squared plus 3 times x squared minus 3. Now I need to take each one and solve. So for this one I would subtract 4 from both sides, right? So I'd get x squared equals -4. When I take the square root of -4, I'm going to get plus or minus 2i. Because the square root of 4 is 2, and I've got a negative under my square root, which makes it imaginary. Always remember, if you take the square root of an x squared, you've got to list the positive and negative solution. X squared plus 3, I would subtract 3 from both sides, right? So that would give me x squared equals -3. take the square root, and x is going to be equal to plus or minus I times the square root of 3. Square root of 3 won't reduce, right? And then lastly, I've got x squared minus 3 equals 0. So add 3 to both sides. So x squared equals 3. So x is going to be equal to plus or minus the square root of 3. Okay? Go ahead and give these a try. If you have questions, let me know, and I would be happy to help you.